Hi everyone, this video is going to help with perimeter and area, and in particular this happens to be section 9.1 in course 1, but I know this is also in geometry, so I don't remember what section this is in geometry. But you'll know that it just kind of covers, here we go, right there, kind of covers the idea of area and perimeter. So what are those? There's something you should have been doing for years. Really, they started at a very young age. So, perimeter, remember, is that distance around. So, distance around an object. You know, like you'd be putting up a fence. That's your area or perimeter, or you're gonna um, anything where you're doing something around. I can only think of a fence right now. That's pretty boring of me. I'll think of something else eventually. Area is the amount of space an object takes up. It's 2D, so 3D is volume. So it's kind of like the amount. I kind of have a hard time defining this one of space an object um, takes up in 2D. So, like a flat space, like this paper, how much space did this paper take up, kind of thing. So, you'd use area for like painting the wall, carpeting, um, planting, planting anything outdoors. Um, so yeah, if you want to put like a pretty edging around something, that's the perimeter, right? But if you want to fill it in with something, that's area. So let's go over a couple questions that they have in here. One thing you do need to know is the distance formula again. That's the distance between 2 points is what? X minus x squared plus y minus y squared all square rooted. We have to have that because it gives us points and it says, all right, well, then what's the area or the perimeter around this? So let's look at our first example here that I have. What if I have the points 3, 2, we'll call that point A, and I have the point 3, 5, and that's point B, the point 6, 5, and that's point C, and the point 6, 2, and that's point D. So there's my 4 points. I'm going to grab some graph paper. What's the perimeter and what is the area of these 4 points? So we can sometimes just count the distance between each one on our graph paper. Sometimes we have to use the distance formula because it doesn't, like, it goes this way, like it has it doesn't follow the grids. So if it follows a grid, which this one does, then it's a lot easier. So let's graph those points. I don't need a whole paper here, but all right, so there's our x and y axis, and so here's our center here at 0, 0, and the first point was at 3, 2, so 1, 2, 3, 2, and that's point A, and the next one was at 3, 5, so 3, what, 1, 2, 3, 4, 5, which is B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's looked off for some reason. 6, 5 would be C, and 6, 2 is D. So look, these ones are pretty. So it goes up and it goes over kind of thing here. So we can perfectly count that this is 1, 2, 3 sections here and 3 sections here. So this is a 3 by 3 rectangle, square, however you want to think of it. It is both. It is a square is probably the best name for it. So we know it's a 3 by 3. Well, remember the length times width is your area. So area would be 3 times 3 or 9, and whatever the unit is on this. This one I don't think had a unit. Feet, inches, you need to include those. Perimeter would be like walking around, so you'd go 3, 3, 3, 3, right? So 3 plus 3 is 6, plus 3 more is 9, plus 3 more is 12. So we'd have 12 for the perimeter. So those are the easier ones where I can count pretty. Some of the harder ones, you can still count some of the sides, but not all. Um, let's look at an uglier one, for lack of a better word. Oh, let me write down the points for the uglier one. So 0 to um, 3, -2, and this is just a triangle, -7, -2. They could get, they made, they do really big ones too, that could be like four-sided or five-sided, or I don't think they do five-sided ones because the area is kind of hard on those, but you're going to have different uh, problems with different points. This one just happens to be a triangle. So let's graph those and we will find the area and the perimeter of this triangle. So one thing we need to remember when we do the area of a triangle is you need that base or that height, or both, excuse me, base and then the height or the 90 degree that goes up. So you have to have that height of that triangle. Sometimes that's a side of it, sometimes it's not. So that's one thing we have to have with the triangle. Let's look at these. I have 0, 2, so 0, 2, and that's A. We have 3, -2. 1, 2, 3, -2, and that's B. And we have -7, -2. 1, 2, 3, 4, 5, 6, 7, -2, ABC. Oops, I put D. Okay. And let's go ahead and draw the triangle so we can kind of look at it a little closer. All right. And then we got to decide. So here's the thing that we need. We need that height. Can you see that that height is right here? So that height we can actually count because it goes straight down. We don't need the distance formula for the height. We can see that it's 1, 2, 3, 4. So the height here is 4. And then we need the base, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the base is 10. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So that is our height and our base. Now, this is for the area. So I can easily do the area, and I'll just write it over here as 10 times 4 divided by 2 or times by 1/2, however you look at that. So 10 times 4 is 40, divided in half is 20. So our area of this object is 20. Now let's do the perimeter. This side we got, it's pretty, it's 10. Now this side and this side, we can't get those easy. That's when you need that distance formula. Okay, so let's find the side AC. AC. So we know A is the point 0, 2, and we know C was the point -7, -2. And let's use those with our distance formula. So we would say, okay, X, I'll just go this way, X minus X, oops, I put a comma in there, X minus X squared plus Y minus Y squared. So let's figure this out here. So -7 minus 0 is -7. -7 squared is 49 plus -2 minus 2 more is -4. -4 squared is positive 16. So 49 and 16, and then I have to square root those. So 49 plus 16 is going to give us 65, and the square root of 65 is a decimal. So this AC is about 8.06. Okay, now let's find AB. So the AB is going to equal okay, so B was 3, -2. So 0 minus 3. So 0 minus 3 squared plus 2 minus -2. Oops, 2 minus a -2. So 0 minus 3, 2 minus negative 2. So 0 minus 3 is just negative 3, which squared is 9. Um, and then plus 2 minus a negative, right? That turns to plus, so that's 4 squared, which is 16. And 9 and 16 make 25. The square root of 25 is pretty, right? It's just 5. So that one's pretty. So now we can do our area, or our perimeter, excuse me. 8.06 plus 5 plus 10 is going to give me a perimeter of, I'll write it over here, perimeter of 23.06. All right. So distance formula, you have to use it with some area, some perimeter, all of the above. You also have to remember those formulas. So you can easily print like a cheat sheet off the internet where you just Google, it's not, I call it a cheat sheet, just it'll be helpful if you had that out, of the formulas. So you can Google like area and perimeter formulas, volume, and you can have all those ready because we are going to do all of those this entire chapter. Okay, so that was 2 questions. Let's do one more or a couple more. Make sure we look for circles are a little different. So we're going to remind you that when I have a circle, okay, part of me really wants to get out my perfect circle maker, but I'm just going to go with it. All right, so if I have one, right, the radius is halfway and the diameter is all the way across. And your formulas for circumference is either diameter times pi, or the circumference could be 2 radius pi. Obviously, 2r is the same as the diameter, so those are the same formula, really. And area is equal to pi r squared. So you need those formulas. So let's say that the radius here is 10. Okay, whatever it is, doesn't matter. What's the circumference? Well, the circumference would equal, this is the radius, so we're going to use this one, 2 times 10 times pi. Sometimes you're going to leave this as 2 times 10 is 20 pi. And that's what you do. That's it. You don't want the decimal of it. You want the actual using pi. That confuses some people. Or sometimes you need to get out your calculator and use 3.14 for pi, or the pi key. So there's 2 ways that you could have that. So I could estimate this at 62.8. Kind of depends on the problem, what they're looking for. For area, we know area is equal to pi r squared, so we have pi times 10 squared. Same idea, we could do 100 pi. Always write the pi after. We could do 100 pi, or we could do 100 times 3.14. I don't know why I need a calculator. That's 320 or 314. Okay, and area, oh, I didn't say the units were always squared. So let's say this is inches. Perimeter is just going to be whatever the unit is, because you're talking distance around. So when we do area, the units would be squared. So these are square inches. Think about what that means. So 314 square inches. Well, we're trying to like fill up space like on this paper. So what it means for square inches is that I'm going to have a square that's 1 inch by 1 inch, right? Here, and I'm going to have 314 of those little squares that cover the shape. So the area has square units, and we always get lazy and put the square, but really if you write it out, it makes more sense. These are squares that are inches or, feet or whatever. Okay, my last question I wanted to show you is to watch out for units. So what if I say I have 12 feet by 5 inches, and I want to know the area of this rectangle. So we'll call this a rectangle. That we know is a 12 feet by 5 inches. Well, a lot of people will just go, okay, well, the area is easy. It's 12 times 5. Well, it's not. You have to have the same units in order for them to be able to compare them and make them in a square unit, right? You don't want, it can't be part feet, part inches on your little squares. Then, so what I do is I'm going to convert this, it'll tell you what it wants the answer in. Let's say our answer needs to be in feet. Okay, so I want area in feet. So I'm going to take 5 inches and convert it to feet. Well, how many inches are in a foot? There's 12. So this one will become 5/12 feet. That's the part of the ruler that it is, right? It's 5 out of 12 total on your ruler. So we're going to times that by 12 feet to get an answer of 5 feet squared, or 5 square feeties are in there. So you're timesing it still by the 12 because that's in feet, and then you make this one 5/12. So you have to convert them into the same. And we could have easily times 12 by 12 and got how many inches were in there, and we could have had our square inches. So you have to pay attention to which one you have to convert. So hopefully this video helps some of you that are really struggling with 9-1.